This tutorial deals with the ratio test, a very powerful test to check for convergence of certain series. We start by stating the ratio test. Assume we have given a series with non-zero terms an. Furthermore, we suppose that the limit as n tends towards infinity of the absolute value of the sequence element an plus 1 divided by an exists, and we call this limit lambda. Here, lambda may be some finite real number or plus infinity. Depending on which value lambda takes on, we will be able to tell whether or not our series converges. We have: if lambda is less than 1, then the series converges. If lambda is greater than 1, then the series does not converge. In the case where lambda equals 1, the ratio test is inconclusive. That means the series may either converge or diverge, but we just cannot tell with this particular test. The essence of the ratio test is to work out lambda, and if it exists and differs from 1, we are able to make a clear statement about the convergence of the given series. Let us say a few more words about this limit. Since all sequence elements an are non-zero, it is legitimate to look at the absolute value of the fraction of any sequence element an plus 1 divided by its predecessor an. So we can build up a sequence of fractions. As you know, for every sequence we can investigate about its limit. Now everything is possible, and this limit may be a finite number, or infinity, or may not exist at all. However, if that limit exists, that means it has some well understood value lambda, then we will be able to apply the ratio test. Let us look at some examples. First, we consider the series taken over the sequence 1 over n factorial for n greater or equal to 1. Then each sequence element is non-zero. In fact, they are all positive. Next, we need to study the sequence of the absolute value of the fractions of an plus 1 over an. Because everything is positive, we don't need to worry about the absolute value. Now an plus 1 equals 1 over n plus 1 factorial, and an equals 1 over n factorial. This fraction of fractions can be rewritten as n factorial over n plus 1 factorial, which simplifies to 1 over n plus 1. Now as n tends to infinity, 1 over n plus 1 tends towards 0. Hence, overall, the limit of the absolute value of an plus 1 over an equals 0. That means our sequence of ratios has a well understood limit. As this limit is less than 1, we conclude by the ratio test that the given series converges. In the second example, we consider the series taken over the sequence n factorial over 10 to the power n. Again, every sequence element is non-zero. In fact, they are all positive. Furthermore, for the absolute value of the fraction of an plus 1 over an, we get n plus 1 factorial over 10 to the power n plus 1 divided by n factorial over 10 to the power n. This can be rewritten as n plus 1 factorial over n factorial times 10 to the power n over 10 to the power n plus 1. The first factor simplifies to n plus 1, the second factor to 1 over 10. Hence we get n plus 1 over 10, which, as n tends to infinity, goes to infinity as well. In particular, the limit of the absolute value of an plus 1 over an exists, and thus we can apply the ratio test. Since infinity is greater than 1, we conclude that the given series does not converge. Furthermore, as the underlying sequence is positive, it follows that the series diverges to infinity. In our final example, we look at the series with the underlying sequence 1 over 2n plus 1. Then all sequence elements are non-zero. Again, they happen to be positive. We need to understand the limit of the absolute value of an plus 1 over an. So we get 1 over 2 times n plus 1 divided by 1 over 2n plus 1. This becomes 2n plus 1 divided by 2n plus 3. If we divide both numerator and denominator of the fraction by n, we obtain 2 plus 1 over n divided by 2 plus 3 over n. Now as n goes to infinity, we get 2 divided by 2, which is 1. That means the limit of the absolute value of an plus 1 over an equals 1, and thus, in this case, the ratio test is inconclusive. In particular, we would have to try a different method to determine whether the given series converges.